Good day, Doctor. My name is Shu Hui with metric number 22004-30, and today I will be presenting on how AI expert system can support sustainable paddy farming by improving productivity and reducing crop loss in Malaysia. In recent years, climate change and inconsistent weather have reduced paddy self-sufficiency from 71% to 56%. Young generation refuse to work in the paddy field because of low income. These challenges caused paddy production in Malaysia drop by 7%. As a knowledge management expert, some AI technologies has been proposed. The first one is AI-based weather forecasting and irrigation scheduling. AI system can analyze satellite and sensor data to predict weather and recommend precise irrigation. For example, IBM Watson platform in India help farmers save water and protect yields. In Malaysia, Mardi is applying similar to in Selangor smart paddy farming project. The second technology is AI-powered crop health monitoring in computer vision. Drones or mobile cameras are used to scan the crops and AI identify issues like rice blaze or nutrient deficiency. For instance, the Plantix app used in Southeast Asia detect over 400 diseases and have reduced yield loss by up to 30%. The third one is AI-driven yield prediction and decision support. AI can predict expected rice yield based on soil, planting time, and weather. Tools like Rice Advice by Africa Rice give farmers customized planting and fertilizer plans. In Malaysia, Mardi is piloting similar forecasting tools for bananas. The first contribution is disease and pest diagnosis. Expert system act like a digital plant doctor. Farmer enter symptoms and the system diagnose likely disease and recommend treatment. One example is ePaddy by UPM, which help farmer detect issues like leaf blaze and give solution plans. Secondly, fertilizer and nutrient management. Expert system provides site-specific fertilizer advice based on soil and crop data. The Nutrient Manager for Rice by IRRI help farmers use the right nutrients at the right time, reducing waste and increasing yield. Lastly, water management and flood rice alert. Expert system can predict flood-prone area and suggest field drainage or irrigation timing. The flood dish rice system uses topographic and weather data to warn farmers and reduce crop loss during heavy rain. Now let me explain the life cycle of an expert system. The first phase is problem identification. We start by identifying the specific issues such as disease diagnosis, irrigation planning, or fertilizer scheduling. Secondly, knowledge acquisition. In this phase, we gather information from agronomists, researchers, and dataset. The third phase is knowledge representation. We translate the expert input into logical rules, often in if-then format. Next, system design and development. The phase that develop the inference engine and user interface. Testing and validation. We test the system using real farm data and experts' feedback to ensure the output are accurate and reliable. And the last phase is deployment and maintenance. We deploy the system via mobile apps or web platform and update it regularly with new findings. In my opinions, I believe the most critical phase is knowledge acquisition. This is where we gather insight to build the system knowledge base. If the information collected is incorrect, the expert system may give inaccurate or even harmful advice to farmers. In agriculture, conditions vary widely. What works in one region may not work in another. That's why local expert knowledge is essential to ensure the system gives relevance and trust recommendation. That's all from me. Thank you for listening.